Right now, as you watch this video, artificial intelligence is writing poetry that moves readers to tears. It's diagnosing rare diseases that human doctors missed. It's driving cars through rush hour traffic. And it's having conversations so natural, you'd swear you're talking to another human. But the origin story of AI, it's nothing like you think. It didn't begin in Silicon Valley with tech billionaires. It didn't start with the internet. It didn't even begin in this century. The story of artificial intelligence started 70 years ago with a single, dangerous question asked by a man who helped win World War II: can a machine think? In the next few minutes, I'm taking you through the complete history of AI. Who started it? When the dream began? Why it nearly died, twice? How it came roaring back? And where it's headed next? This is the story of humanity's most ambitious invention. Before AI had a name, before computers existed in any recognizable form, humans were obsessed with one idea: creating intelligence from scratch. Ancient Greek myths described Talos, a giant bronze automaton that guarded the island of Crete. Medieval alchemists claimed they could breathe life into clay. In the 1700s, European inventors built elaborate mechanical dolls called automata that could write letters, play instruments, and perform complex movements. But these weren't intelligent. They were sophisticated wind-up toys. They followed predetermined instructions with no ability to learn, adapt, or think. Then came World War II, and everything changed. The war demanded something unprecedented: machines that could calculate faster than any human. Breaking enemy codes, computing artillery trajectories, processing massive amounts of information in minutes, not months. At Bletchley Park in England, a brilliant mathematician named Alan Turing built machines that helped crack the Nazi Enigma code, arguably shortening the war by years and saving millions of lives. But Turing saw something others didn't. If machines could process information this powerfully, could they eventually think? In 1950, Turing published a paper that would change history. He proposed a test: if you conversed with a machine through text, and you couldn't determine whether you were talking to a human or a computer, then that machine could be considered intelligent. The Turing test wasn't about consciousness or feelings. It was about behavior. If it acts intelligent, it is intelligent. 6 years later, in the summer of 1956, something extraordinary happened at Dartmouth College in New Hampshire. 10 researchers gathered for a workshop with an audacious proposal. The invitation read: "We propose that a 2-month, 10-man study of artificial intelligence be carried out. The study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it." The leaders were John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester. They coined the term artificial intelligence at this workshop. This was the moment. The field was born. Not with a machine, but with a belief that human intelligence could be reverse engineered, formalized, and recreated in silicon. The Dartmouth Conference of 1956 is to AI what the Big Bang is to the universe. Before it, AI didn't exist. After it, everything changed. The 1960s and early 70s were AI's golden age. Optimism was stratospheric. Early AI programs achieved things that seemed impossible. They solved algebra problems. They proved mathematical theorems. They played checkers and won. They understood simple English sentences and could respond coherently. In 1966, MIT professor Joseph Weizenbaum created Eliza, a chatbot that simulated a psychotherapist. People knew it was a machine, but they still opened up to it emotionally. Some users believed they were talking to a real person. Governments and corporations poured millions into AI research. The US Department of Defense funded massive projects. Major universities established AI labs. Researchers made bold predictions. Marvin Minsky said in 1970, "In 3 to 8 years, we will have a machine with the general intelligence of an average human being." Herbert Simon predicted in 1965 that machines will be capable, within 20 years, of doing any work a man can do. The future looked inevitable. Human-level AI wasn't a question of if. It was a question of when. But there was a problem. A massive, fundamental problem that nobody wanted to admit. The real world was far messier than anyone imagined. By the mid-1970s, the cracks were showing. AI worked beautifully in controlled laboratory environments. But the moment you took it into the real world, it collapsed. Early AI couldn't handle ambiguity. It couldn't deal with incomplete information. It couldn't understand context. A program that played chess brilliantly couldn't recognize a cat in a photo. A language system that translated simple sentences broke down completely with idioms or slang. And the computational power? Laughable by today's standards. The most powerful computers in 1975 had less processing power than your phone's calculator app. In 1973, the British government commissioned mathematician James Lighthill to evaluate AI progress. His report was devastating. He concluded that AI had failed to achieve its grandiose objectives and that most research was of limited practical value. Funding evaporated overnight. The US government slashed AI budgets. Universities shut down entire AI departments. Corporations abandoned projects. Careers ended. This period, from the mid-1970s to the early 1980s, became known as the AI winter. Not a recession. A winter. Long, cold, and brutal. Researchers couldn't even say they worked in AI. They called it informatics or computational intelligence instead. The term artificial intelligence became toxic. But here's what most people don't know: AI didn't die. It went underground. And it got smarter. During the 1980s and 90s, AI survived by becoming practical. Instead of chasing human-level intelligence, researchers built expert systems, programs designed to solve specific, narrow problems using rules created by human experts. MYCIN diagnosed blood infections. Dendral identified chemical compounds. XCON configured computer systems for Digital Equipment Corporation and saved the company millions. These weren't sexy. They weren't headline-grabbing. But they worked. They made money. And they kept AI research alive. Then, on May 11, 1997, something happened that brought AI back into the spotlight. IBM's Deep Blue faced world chess champion Garry Kasparov in a rematch. The year before, Kasparov had won. He'd dismissed the machine as powerful but ultimately predictable. This time was different. Deep Blue won. 4 games to 2. A machine had defeated the greatest human chess player in history. The New York Times called it the brain's last stand. Kasparov himself said after the match, "I could feel, I could smell, a new kind of intelligence across the table." AI wasn't just back. It was winning. Around the year 2000, three forces converged that would transform AI forever. First, data. The internet exploded. Suddenly, there were billions of images, millions of hours of video, trillions of words of text available for training AI systems. Before, AI researchers were starving for data. Now they were drowning in it. Second, computing power. Moore's law kept delivering. Computers got exponentially faster and cheaper. Graphics processors, originally designed for video games, turned out to be perfect for AI calculations. Third, new algorithms. Researchers moved away from programming rigid rules and toward machine learning, teaching AI to recognize patterns in data, just like humans learn from experience. Instead of telling a computer a cat has pointy ears, whiskers, and fur, you showed it 10,000 pictures of cats, and it learned what catness looks like. By the mid-2000s, AI could filter spam, recommend products, and recognize faces in photos. It wasn't revolutionary yet, but it was everywhere. Google search, Amazon recommendations, Facebook's photo tagging. You were using AI every day without realizing it. The stage was set for the revolution. In 2012, everything changed. At an image recognition competition called ImageNet, a team from the University of Toronto submitted an entry using a technique called deep learning. Their system didn't just win. It crushed the competition. Error rates dropped from 26% to 15% overnight. Deep learning was inspired by how the human brain processes information, layers upon layers of artificial neurons processing data, each layer learning increasingly complex patterns. Suddenly, AI could recognize objects in images as well as humans. It could translate languages in real time. It could transcribe speech accurately. It could generate realistic images from text descriptions. In 2016, Google's DeepMind shocked the world with AlphaGo. The ancient game of Go has more possible positions than atoms in the universe. Experts said I wouldn't master it for another decade. AlphaGo defeated Lee Sedol, the world champion, 4 games to 1. In one move 37 in Game 2, AlphaGo played something so unconventional, so creative, that experts thought it was a mistake. It wasn't. It was genius. A machine had made a creative leap. The AI researcher Demi Hassabis called it AI's Sputnik moment. The world realized, this isn't just automation. This is something new. AI had arrived. Today, in 2025, AI is no longer experimental. It's infrastructure. It's in your pocket, on your wrist, in your car, and throughout your home. AI writes code for programmers. It generates art for designers. It composes music for creators. It diagnoses diseases for doctors and reviews contracts for lawyers. In 2022, AI entered the mainstream in a way it never had before. ChatGPT launched in November and gained 100 million users in 2 months, the fastest adoption of any technology in human history. Suddenly, everyone understood. AI wasn't coming. It was here. But with power comes questions. Serious questions. Jobs are being automated. Not just factory work, knowledge work. Writing, analysis, design, even programming. If AI can do your job better and faster, what happens to you? Privacy is eroding. AI systems are trained on data scraped from the internet, your photos, your words, your art, often without permission or compensation. Bias is embedded. AI learns from human data, and human data contains human prejudice. AI systems have shown bias in hiring, lending, and criminal justice. And control. Who controls AI? Corporations, governments, everyone, no one? These aren't philosophical questions anymore. They're urgent, practical problems that we're solving, or failing to solve, right now. So what comes next? In the next 5 years, AI will become invisible. Not because it disappears, but because it's everywhere, woven into the fabric of daily life. Your AI assistant will know your schedule, your preferences, your work style. It'll draft your emails, summarize your meetings, and handle routine tasks while you focus on what matters. Education will transform. AI tutors will provide personalized learning for every student, adapting in real time to their pace and style. The cost of high-quality education will plummet. Healthcare will improve dramatically. AI will detect diseases earlier, recommend treatments faster, and monitor patients continuously. What used to take a team of specialists and weeks of appointments will happen in hours. Most people won't think about AI. They'll just notice that their doctor is more accurate, their kids are learning faster, and their work is less tedious. AI won't replace humans. But humans using AI will absolutely replace humans who don't. Looking further, 10 years from now, the world will be almost unrecognizable. Entire industries will be reshaped. Transportation, manufacturing, agriculture, finance, every sector will be rebuilt around AI. AI won't just assist knowledge work. It'll collaborate creatively. AI researchers, AI designers, AI strategists working alongside humans, contributing ideas, challenging assumptions, pushing boundaries. The line between human work and AI work will blur completely. You won't ask, can AI do this? You'll ask, how can AI and I do this better together? But here's the critical point: this future isn't predetermined. We're building it right now. The choices we make today, about regulation, about access, about ethics, will determine whether AI empowers everyone or concentrates power in the hands of a few. The next decade isn't about AI becoming more powerful. That's inevitable. The next decade is about whether we're wise enough to guide that power toward good. Artificial intelligence isn't a sudden invention. It's a 70-year human story, filled with dreams, devastating failures, stubborn persistence, and breathtaking breakthroughs. The question is no longer, can machines think? The real question is, how will we choose to think with them? And that story, it's just beginning. Thanks for watching. If you want to understand how other technologies are reshaping our world, subscribe to Think How, When, Where and Why. Because the future doesn't just happen, it's built by people who understand it.